Good day, stats students. So today, this is a precursor to sections 11.3 and 11.4. We just have to talk about some things before we just jump into those two sections. So often researchers like to compare two populations, all right? In these two sections, we're going to be comparing two population means. Now, researchers aren't limited to just looking at two population means. They might look at two population proportions. They might look at a different parameter that is coming from two different populations. All right. And so here we're going to look at population means. So how can we have two populations? Well, for instance, instead of looking at the height of all University of Akron students, maybe the researcher wants to compare the heights of all males versus all female University of Akron students. And so basically the researcher has defined two very distinct groups. Once you have two distinct groups, now you have two distinct populations. So instead of looking at all University of Akron students and making it one population, we have two populations, males and the females. All right, so the reason why we have to really talk about the some stuff before we just jump into 11.3 and 11.4 is because we have to talk about independent versus dependent samples. All right, and the difference between the two. Let's start with dependent samples. So what does it mean to have dependent samples? Well, let me give you an example here. Let's say that we have an example where we have exactly the same people in both samples. Sounds kind of funny. And actually, if we have exactly the same people in both samples, we have exactly the same people in both populations too, okay? And we have this before and after effect. So for example, let's say that we have a group of students who did poorly on the SAT the first time they took it. So what the students decided to do was take a course. And then after the course, they took the SAT again. And so we have this before and after situation. We have their SATs scores before they took the course, and then we have the SATs after they took the course. And so we have the students before, students after as the two populations. All right. Now, we could have a different example where we don't necessarily have to have exactly the same people, but we still have this natural pairing going on. And let's say that we compared husbands and wives' annual salaries. So, let's say that we make the wives population number one. All right, so we got population number one, and we look at the first wife. Well, who are we going to compare her salary to? We're going to compare her salary to her husband's salary, and so on and so forth. All right, throughout the entire populations then of husbands and wives. All right. So there's two examples where we have dependent samples. And so essentially, with the first example, we have person number one in population number one. Population number two, we still have person number one. All right. But we're going to just simply go ahead and compare their SAT scores. That's what's the difference between the two. We got the SAT scores before, we got the SAT scores after. All right, so we have this natural pairing going on. And when this happens, you can only be compared. So this person right here can only be compared to obviously themselves, okay? But let's say that we had the second example where we had wife one, husband one, wife two, husband two. So what you got to think of is that there's one and only one person that you can be compared to, okay, in the second population. So if you're in the first population over here, let's say that you're wife number three, all right, that there's only one husband that you can be compared to, all right, and that would be husband number three, okay? So if you have one and only one natural pairing going on, and so wife one has exactly just one person to be compared to in population number two, that would be husband one, and wife two has only one person to be compared to in population number two, husband two. We have dependent samples. All right. All right. What about independent samples? No natural one-to-one pairing, all right? Uh, so an example of this would be comparing UA males versus UA females. So think about yourself, all right? Think about yourself that I don't care if you're male or female, is there one and only one distinct person of the opposite gender that you can be compared to? I mean, it doesn't even make sense, right? It doesn't even make sense, right? And so, um, and so, as long as you don't have this natural pairing going on, you've got independent samples. It's as simple as that. So dependent samples, we're going to cover in section 11.3. And independent samples, we're going to cover in section 11.4. Now, 11.3, if we have dependent samples, the actual confidence interval and test that we're going to do is what's called a paired t-test, all right? And we're going to run both confidence interval and what's called a hypothesis test. I know I haven't talked about a hypothesis test yet, but I will, all right? And so down here, we have independent samples, okay, which is a section 11.4. Now there's two different ways of doing this, and that'll be on the next slide. All right, the one way that we could do this is that we can run a two-sample t-test, and this is run most often. And this assumes that the two population variances are unequal, all right? And, oops, I didn't mean to do that yet. And so this assumes the two population variances are unequal. So meaning you don't have too much information with regards to the variation within the two groups, which you probably aren't going to have, okay, too often, and that's why this is run most often. Now there is another way of running this. It's called a pooled t-test, and this is rarely conducted in real life. Okay, in real studies, this is rarely conducted. The reason why is because you have to assume that the two population variances are equal to one another. So you have to have some real intimate knowledge of both populations ahead of time and how they vary. And so just imagine this, is that when we only worked with one population, I told you that rarely do we know what sigma is, right? And so what do we replace it with? We replace it with S. Okay, here, notice, not alone do we have to know information about one population, we have to know information about the second population's variance, and we have to understand that they're pretty much equal to one another in order to use this technique here, okay? That's why it's rarely actually conducted in real studies, okay? There is a hypothesis test to actually test if the two population variances are equal, but it's highly dependent upon large sample sizes. And so it's rarely conducted. And so really what we're going to focus in, I will talk about, I'll have a slide or two about the pooled t-test, all right? But really what we're going to focus in on is the two-sample t-test, all right? And assuming that the population variances are unequal, or we just don't have too much knowledge about these variances, and so we're just going to assume that they're unequal, okay? All right, so let's see if we can figure out these next examples and figure out if these are independent or dependent samples. So first one, the television program. So I watched a program and it's called Brain Games. So the television program Brain Games did a study where they had 40 randomly selected adults drive a go-kart horse, but the steering wheel actually steered the opposite way. If you turn the wheel to the right, the car actually turned left, and vice versa for that matter. Then they studied 40 randomly selected children from the ages of 10 to 12, and they drove the same course under the same conditions. The two population means were compared to see if a significant difference existed. So, what are the two populations? What do you think? What are the two populations? Two populations are, we got all adults and all children from the ages of 10 to 12. Okay? And B, is this an independent, meaning we're going to do a two-sample t-test, or a dependent study, paired t-test? We're going to assume that we know nothing about the variances of these driving times, because they basically they drove a course, okay, and they wanted to see how long it was going to take them to uh, finish the course, right? So we don't know what the variances are going to be for these two different groups, okay? So we're just going to assume that we would have to run the two-sample t-test. All right, so hopefully you said that in this case, this is the independent samples, the two-sample t-test. Now why? Why would this be the case? Well, because we have 40 randomly selected adults, we have 40 randomly selected children from the ages of 10 to 12. There's no natural pairing going on, okay? And there you go. All right. By the way, the children's mean time to finish the course was significantly lower than the adults' mean time. And and uh, uh, and if you think about it, why was this the case? Well, adults are have been driving for years and years. They've been programmed that turn the wheel to the right, it's going to go to the right. Now for the children, it didn't make sense if you turn the wheel to the right that it would go to the right, but they weren't used to driving, and so they said, oh, okay, so if I turn the wheel to the right, the car will go left. So they learned a lot quicker because they didn't have to be basically deprogrammed, if you will. All right, anyways, how about the second one? So there's a show that I used to watch called Mythbusters, and they did a study in which the host did a series of cognitive tests in which they were timed. Now, all the hosts were sleep deprived for 24 hours. Afterwards, they were all tested again doing the same type of tasks. Again, they were timed. The mean time before being sleep deprived and after were compared to see if even mild sleep deprivation increased the mean time to complete the task. So assume that the results could be applied to all adults. So what are our two populations? We've got all adults before and after sleep deprivation. And what do you think? Is this the independent or dependent case? Hopefully you said, that sounds like the dependent case, right? Because we have exactly the same people, right? We got this cognitive test before, cognitive test after the sleep deprivation, and there you go. All right. I must say that if I was going to do this for real, I would randomly assign if they were sleep deprived first or sleep deprived second. That would make a better experiment. Okay, but this is a television show. They got time restrictions and things like that. Okay, but certainly this would be a dependent samples case, paired t-test. Okay. Oh, and by the way, it definitely took longer on average after the sleep deprivation. All right, so this is what we're going to study. We have two different populations. We have means that are coming from these two populations, and we're going to compare the values of these two population means and see if we can come up with a conclusion with regards to their differences. Okay, to their differences. That's where we're headed in the next following sections. Thank you for your time.